minus 1 upon m1, which is the slope of the required line. And using that and all other formats we have already discussed in my last session, which is the all other forms of the line. For example, we have discussed the point slope form, 2-point form, slope intercept form, 2-intercept form. Using all these forms, we can easily find the equation of the required line if we have the slope of the line. Okay, so this is the everything about the parallel and perpendicular lines. Our next topic of today is angle between two lines. Okay, so angle between two lines. If we say that the angle between two lines is theta, then how to find the value of theta? That is our main goal today. Okay, so let we take two lines. The angle between two lines is theta. Here if we say that the slope of the first line is equal to m1, which is making an angle beta with the positive x direction, and the slope of the line second line is m2, which is making an angle of alpha with the positive x direction. This is just saying that this is the m1 slope line, m2 slope line. So this is the angle here with the positive x direction is beta, and the angle with the positive x direction is alpha, and we need to find here the value of theta, which is the angle between two lines. So here the formula for finding the angle between two lines is tan theta is equal to in mod m1 minus m2 upon 1 plus m1 into m2. So this is the our formula to find the angle between two lines. And if you want to find the theta, then theta is equal to tan inverse in mod m1 minus m2 upon 1 plus m1 into m2. We can also give the proof of this formula. If we look at the proof, then here the m1 is equal to tan beta, because the slope of first line is equal to m1, the angle is beta, so m1 is equal to tan beta, and clearly m2 is equal to tan alpha. And by the trigonometry we can say that here beta is equal to alpha plus theta, which is the external angle of the triangle. So beta is equal to alpha plus theta, so theta is equal to beta minus alpha, and we need the theta. Okay, so here tan theta is equal to tan beta minus alpha, so tan theta is equal to tan beta minus tan alpha upon 1 plus tan alpha into tan beta, which is the our formula for tan beta minus alpha, which is tan beta minus tan alpha upon 1 plus tan alpha into tan beta. So here tan beta is equal to m1, tan alpha is equal to m2. So our formula will be tan theta is equal to m1 minus m2 upon 1 plus m1 into m2. And for the acute angle we will take modulus, because tan theta is equal to in mod m1 minus m2 upon 1 plus m1 into m2, because for the acute angle, which will be always we will take positive, so that is in the modulus m1 minus m2 upon 1 plus m1 into m2. So this is the very easy proof that how to find the formula for angle between any two lines which have the slopes m1 and m2. So tan theta is equal to in mod m1 minus m2 upon 1 plus m1 into m2, where m1 and m2 are the slopes of the given lines. Okay, so now we will look at the example which is related to the angle between two lines, and using that we will solve some examples which are very useful for the exam point of view. So let us look at the PPT. So our first example of for the angle, which is question is find the acute angle between two straight lines root 3x minus y plus 1 is equal to 0, and x minus root 3y plus 2 is equal to 0. This example was asked in the July 2011. So we will solve this example practically here. So if we look at here, then we have given that the equation of lines are root 3x minus y plus 1 is equal to 0, and the second line is x minus root 3y plus 2 is equal to 0. We want to find the acute angle between these two lines. This example was asked in July 2011, right? So first let the slope of the line root 3x minus y plus 1 is equal to 0, say the slope is m1. So here m1 is equal to minus a upon b, which is the slope of the general equation line. If the general equation of line is ax plus by plus c is equal to 0, then the slope of the line is minus a upon b. So here slope is equal to minus a upon b is equal to minus root 3 upon minus 1, which is equal to root 3. So here m1 is equal to root 3, which is the slope of the first line. In the same way, if the slope of the second line we say that is m2, then here m2 is equal to minus a upon b. So here a is equal to nothing but 1 and b is equal to minus root 3. So we will get minus a upon b is equal to minus 1 upon minus root 3, which is equal to 1 upon root 3. So we have the slopes of both lines which is given in the example, and our idea is to find the angle between these two lines. Now we have m1 and m2. So our formula to find the angle between these two lines, as we have discussed, that is tan theta is equal to in mod m1 minus m2 upon 1 plus m1 into m2. Here m1 is equal to root 3 and m2 is equal to 1 upon root 3, right? So here tan theta is equal to in mod m1 is equal to root 3 minus m2 is equal to 1 upon root 3 upon 1 plus m1 into m2. So m1 1 plus m1 is equal to root 3 and m2 is equal to 1 upon root 3, right? So here we will get 3 minus 1 upon root 3 upon this root 3 cancel. So this is 2. So we will get 2 upon 2 root 3, which is equal to 1 upon root 3, that is tan theta. Okay, so it is clear that theta is equal to tan inverse 1 upon root 3, and we all know that tan inverse 1 upon root 3 is equal to pi by 6. So angle between these two lines is equal to theta, which is equal to pi by 6. So if we want to find the angle between two lines which is already given or their slopes is given, so here we have given two lines, but and using the equation of that two lines we have find slopes of their both lines, and then we have used the formula in mod m1 minus m2 upon 1 plus m1 into m2, and then we have find the value of tan theta, which is equal to 1 upon root 3. So theta is equal to tan inverse 1 upon root 3, and theta is equal to pi by 6. So answer of this question, this example, is theta is equal to pi by 6, which is equal to 30 degree. If we look at one more example related to the angle between two lines, this is the second example. The question is, find the equation of the line passing through the point 2, 3 and making an angle of 45 degree with the line 3x plus y minus 1 is equal to 0. Here is the question is twisted, because we have not given the slope of the required second line, which is making an angle of 45 degree with the given line 3x plus y minus 1 is equal to 0. કહેવાનો મતલબ એ છે કે અહીંયા જે લાઇન આપણે શોધવાની છે એ લાઇનનો સ્લોપ આપને આપેલો નથી. આપને માત્ર એટલું જ આપેલું છે કે જે રિક્વાયર્ડ લાઇન છે એ 2, 3 માંથી પાસ થાય છે અને તે લાઇન 3x પ્લસ y માઇનસ 1 ઇઝ ઇક્વલ ટુ 0 સાથે 45 ડિગ્રીનો એંગલ મેન્ટેન કરે છે. એનો મતલબ કે આપણે અહીંયા એંગલ આપેલો છે પણ સેકન્ડ લાઇનનો સ્લોપ આપેલો નથી. તો આપણે ફર્સ્ટ લાઇનનો સ્લોપ મેળવીશું. એંગલ ઓલરેડી આપણી પાસે છે, તો આપણે એંગલ અને પહેલી લાઇનનો સ્લોપનો યુઝ કરી બીજી લાઇનનો સ્લોપ મેળવશું, અને પછી આપણે પોઈન્ટ x1 y1 ઇઝ ઇક્વલ ટુ 2, 3 આપેલા છે, તો એનો યુઝ કરી અને આપણે પોઈન્ટ સ્લોપ ફોર્મનો યુઝ કરશું. y માઇનસ y1 ઇઝ ઇક્વલ ટુ m x માઇનસ x1 ને એનું આપણે સોલ્યુશન મેળવશું. તો આ એક્ઝામ્પલ આપણે પ્રેક્ટિકલી સોલ્વ કરશું તો આપણે આઈડિયા આવશે. ક્વેશ્ચનમાં આપણે આપેલું છે કે ધ રિક્વાયર્ડ લાઇન ઇઝ making an angle of 45 degree. So here theta is equal to 45 degree, which is given, and this angle is with the line slope of the line which is given 3x plus y minus 1 is equal to 0. So slope of this line, we said the slope of the line is equal to m1, then m1 is equal to minus a by b is equal to minus 3 upon 1 is equal to minus 3, which is our m1. So normally our formula is tan theta is equal to m1 minus m2 upon 1 plus m1 into m2 in mod, but we have not given m2. Our idea is to find the value of m2. We have given here theta and m1. So as per our formula, so if we suppose that the slope of required line is m, okay, then tan theta is equal to, in mod, m minus m1 upon 1 plus m into m1. We can also say that is m2, but it is okay to take m, which is the slope of the required line. Here theta is equal to 45 degree given, and m1, which is the slope of the first line, which is minus 3, is also given. So we will put m1 is equal to minus 3 here and here, and we will put theta is equal to 45 degree here. So we will get tan 45 degree, which is equal to, in mod, m minus m1. m1 is equal to minus 3. So m minus minus 3, which is equal to m plus 3 upon 1 minus m into upon 1 plus m into m1. So which is equal to 1 minus m is equal, m1 is equal to minus 3. So which is equal to minus 3m. And we all know that tan 45 degree is equal to 1. So 1 is equal to, we will get 1 is equal to m plus 3 in mod m plus 3 upon 1 minus 3m. So implies in mod 1 minus 3m. By simplifying this one, we will get 1 minus 3m mod is equal to mod of m plus 3, and we have two possibilities, that 1 minus 3m is equal to m plus 3, or 1 minus 3m is equal to minus m minus 3, because one possibility with the plus sign, second possibility with the minus sign. So here if we put the minus sign, then that is minus m minus 3, and if we put the plus sign, then is m plus 3. So we have two possibilities. For the first one, we will get 4m is equal to minus 2, so we will get m is equal to minus 1 by 2, and if we put for the second one, then we will get 2m is equal to 4, so we will get m is equal to 2. So we have two slopes, so we can say that we have the two optional cases. If the one case is when the slope is minus 1 upon 2, and second one when the slope is 2, and we have given that the required line is passing through the point 2 3. Okay, so now we have the point x1 y1 is equal to 2 3, and the slope of the required line is minus 1 upon 2, and we have find two possibilities, minus 1 upon 2 or 2. So we need to, if we need to find the equation, we have two equation we will get using these two slopes. Then so here we get m is equal to minus 1 upon 2 or m is equal to 2, and the point x1 y1 is equal to, we have given x1 y1 is equal to 2 3. So by the point slope form, we will get y minus y1 is equal to y minus y1 is equal to m x minus x1. So here y1 is equal to